Hello everybody. I know it's late and you're all pretty tired after the day of so many awesome talks. But I hope you'll bear with me for a little bit longer. I'll try not to be too long so that we can all go home or go party. I don't know. So yes, my talk was, is Elixir Exploring Actor-Based System. But after the morning talk by Božidar, I was inspired a bit to change it slightly. So my talk will be Elixir, the good parts. No, really. But I want to touch on that a little bit and say that I really like the Elixir community. I think this is one of the great things about Elixir, and the community that is built around the language, which is very open and welcoming, and tries to approach new people in a very open way. And especially one person, which is José himself, the creator of Elixir. And hearing Božidar talk about the problems with communication between the core team and the community, it made me appreciate how much easier it is in Elixir, how open the core team is to any patches and changes that are coming from the community. So going back to the talk, I was already introduced, so I won't talk about it, but I look like that on the internet, and you probably can tell that an update is in order. So I see some people with like cameras around, so let's hope I'll get one. And since recently I'm working for this company from Norway, and we're doing development with Elixir primarily. So yes, talking about Elixir, we need to start and think a little bit about where we're coming from and why Elixir is seeing more and more adoption recently. And in my opinion, this is Elixir. This is true about Elixir and about a lot of other functional languages, because what I'm going to talk about is shared by most of them. Is that if we look at the chart, you don't need to read the numbers, but the trends are important. The green line shows the number of transistors in CPUs. Right? And we can see the growth is exponential, as it should be. But if you look at the dark blue line, which is the CPU speed, the clock speed, it plateaued around 2005. Right? So where are those additional transistors going to? Well, they're primarily going to other cores of our processors. But with multi-core, there comes this huge problem of the traditional threads model of thread safety, right? And if I assume most of us try to program with threads, and it's scary. It is difficult to get it all right. All the locks and mutexes and semaphores and atomic variables. It's very hard, it's very easy to make small mistakes that are not going to show up until 1 a.m. in the morning, right, under high load, and then you cannot reproduce it again because it was all those things coming together that produced the bug. But fortunately, the classical threading model is not the only model of concurrency we have available. And one of the other models is the actor model. And I would like to talk a little bit about it. It is not the only, though. We have all those mathematical models developed over years and way back. And some of them are used today in software we use. So for example, communicating sequential process, or CSP, is implemented by Go, or software transactional memory, for example, by Haskell and Clojure. But we want to focus today on actor model, which is implemented by Erlang and Elixir. Not only, though. I think those are the biggest actor model implementations out there, and Elixir and Erlang being a separate implementation is a bit of a stretch because it's actually exactly the same. But you also get Akka for Scala, and interestingly, you also have Orleans for the .NET environment. And I think this is one of the things that showcases that there is no strong relation between actor model and functional programming. But functional programming makes actor model so much nicer. But so what is it about functional programming that makes this integration easy or interesting or easier, right? I think there are two primary factors, right? Functional programming is first about explicit state and then about transformations instead of mutations. And we already heard it today that if nothing changes, right, you cannot have things changing underneath you. So you don't have the classical data races problem. And I'd like to quote José here. Functional programming is associated with concurrency, but it was not by design. It just happens that by making the complex parts of our systems explicit, solving more complicated issues like concurrency becomes much simpler. I think this is very important that, and we will see this again today in my talk, that the place where Erlang and Elixir are right now, of the concurrency model that they have and the functional programming, they are not by choice in way or by design. It just happens that by trying to solve a certain class of problems, this is a great solution. So you cannot have an Erlang or Elixir talk without mentioning Joe Armstrong, the father of one of the fathers of Erlang. And I would like to talk a little bit about Erlang now. So Erlang was developed in the 80s, and when they started, they didn't set off to create a new programming language. They had one goal and one problem to solve, which was we want to run software that doesn't crash, right? And they wanted to run this software on telecom switches. So this is an example telecom system, right? My artistic skills are awesome. But if we look at that image, right, we have some switches, we have clients, we have some backend systems. But if we change the names only slightly, right, we have what we have today in our modern web, right? We have servers, we have browsers, some mobiles, and some backend endpoints in the end. And that is why Erlang is seeing a sort of renaissance in the last 5 to 10 years. And why Elixir also appeared leveraging this awesome platform. And I think one of the most interesting things about Erlang to me was that if you look hard enough at all the big companies, they have Erlang somewhere in their stack. Right? But on the other hand, Erlang is not super popular, right? There are not tons of Erlang programmers. And you have to wonder, why is that, right? Why is that is it that it makes the problem so easy to solve that you don't need all those programmers? Or maybe there are some other issues. But the truth is, and I don't know the answer to that, but I know that Erlang is in most big companies use Erlang somewhere in their stack. And you, of course, mentioning Erlang, you have to mention WhatsApp, and there are 2 million connections on a single server post, which was a long time ago, but I think it's a very nice post that shows some of the underlying features of Erlang that makes such things easy. So let's transition to Elixir. Elixir was created, as I mentioned, by José, And there's also this story of trying to solve a problem. And Erlang was a great solution, according to him. But what José likes to say is that he loved the things he saw in Erlang, but he hated the things he didn't see. Right? He thought Erlang is missing a lot of things, and Elixir is an attempt to bring those missing things to the Erlang platform. And I mentioned some companies using Erlang, so to have a symmetry, I mentioned some companies using Elixir in production, and the same story about 2 million connections on a single server, which is, I think, over a year ago when the Phoenix team was optimizing the WebSockets. And we got similar stories this year at ElixirConf in the US, when there were stories about scaling Phoenix channels and Phoenix presence. So yes, we can say that Elixir has those two sides. There is the functional side and the functional language we get. And there is the concurrent side and the concurrent language. But they fit together, right? It is a single language. These are not two separate entities. So this is a process, right? From now on, circles are processes. And inside the process, we're running sequential code. Well, we're running functional code, right? And the important thing is that inside a single process, the code is really sequential, right? We don't get the async callbacks hell that you would get, right? You write your code like you always used to, or with the pipe operator, it would look like that. But I think the important thing is that the runtime and the semantics given by the runtime allow you to write code that looks sequential, but actually isn't, and you get guarantees that it will do the right thing. And Sasha is going to talk tomorrow about that a little bit more. But we don't have a single process when we're running Erlang. We have a lot of them. Actually, it's not unusual to have millions of processes on a single Erlang system. And the thing about the actor model that comes in here is that processes communicate by sending messages. Each process is completely separate from all the other processes. It has a separate memory, separate garbage collector, nearly completely separate runtime, right? And the only way to communicate with the outside world and with anything else is by sending messages to other processes or to those special processes that can talk to the outside world, or ports, but this is not that important. And this is everywhere, right? Writing to a file in Erlang is sending messages to a process that represents the file, right? Or writing to standard out or reading from standard in. It's all sending messages. There's a single abstraction that is present everywhere. But looking at that image, you might start wondering, it looks extremely messy, right? There are those dots everywhere, talking with who knows what, and it's hard to make sense of that. So here comes the OTP, which stands for Open Telecom Platform, which is a fancy way to say a standard set of solutions for writing maintainable and resilient software that was developed in Ericsson on top of Erlang language. Today, they mostly come together, and you cannot really separate one from another. But in its core, OTP is a set of libraries for writing resilient software. So let's imagine a situation when we have a bunch of processes. We have a process talking to the database, a process handling a web request, something talking through WebSockets, and some processes sending emails. And we agreed we need to organize it. And the way we organize things in the Erlang world and Elixir world is by building supervision trees. So we add another process that its sole role is to monitor those two or more processes and to react when they die. Right? And when any of the processes die, the job of supervisor is to restart it. It's a very simple rule, but it's surprisingly effective. And the truth is, you all know it under a different name, which is, have you tried to turn it off and on again? Right? And Erlang brings that to the extreme and built the whole system around this single rule. But the truth is, it solves a lot of problems, because a lot of bugs in our software are intermittent and are solved by trying again or trying a little bit later. But it still doesn't look like a system, right? We have just a bunch of connected processes. But we talk about supervision trees in Erlang, because you have a supervisor, and that supervisor is supervised by another supervisor in a turtles all the way down style. And you gather a bunch of that single tree that does something. And is called an application in the Erlang Elixir world. An application is a unit of code and runtime processes that is started and stopped together as a unit. Right? And on a single node, you have many of those running alongside. So one could be an LDAP server, another could be WebSockets, something else could be handling HTTP requests, and have all those applications running side by side built into this tree shape, communicating together. And here I would like to go back to this image, because there is another thing important to show in here, is that if we remove the supervisors and that structure from the image, we see those processes floating around, communicating with each other. And a very interesting thing about the runtime of Elixir is that it doesn't really matter if it's on the same node or on different node, on different boxes, right? Different machines. It's mostly transparent to the programmer. So it makes it extremely easy to scale your software to multiple machines. So we talked about process, we talked about supervisors, and a little bit about the distribution. And I would like to sum up this part with a quote by Joe Armstrong, which I think shows the shift in mentality one has to go through coming to Elixir and Erlang, is that we do not have one web server handling 2 million sessions. We have 2 million web servers handling 1 session each, right? And that sounds a lot simpler, and it actually is. So in the second part of the talk, I would like to focus a bit on goals of Elixir. So there are 3 primary goals of Elixir, which are compatibility with Erlang, extensibility, and productivity. Well, at least those were the goals of Elixir until this happened 2 weeks ago, and José came on stage and said that's no longer true, and we have 3 new goals of Elixir. Or 2 new, because productivity stayed and is now at the top. But the 2 other things that became the goals for the platform are maintainability and reliability. And the reasoning for the change was that we mostly achieved the extensibility and the compatibility part, and it's not going away. So we might as well focus on some other things and identify some other patterns in the recent releases of Elixir and make them the focus on the core team. So I would like to talk now a little bit about those old goals and those new goals and what they actually mean. So the first one is compatibility. And as I said, this means compatibility with Erlang. And the simplest way this compatibility can be expressed is that all the data types in Elixir and Erlang are exactly the same. Right? The functions are exactly the same underneath. A map in Elixir is a map in Erlang. This makes going from calling libraries from one language in the other very easy in case of going from Elixir to Erlang. In case of going from Erlang to Elixir, it's also easy, but there is a problem of tooling that didn't develop yet. But in principle, the languages are really the same when it comes to how they run the code. What is different in Elixir is the parts that come now, so the other goals. So the first one is extensibility. And this is achieved in Elixir. This is the simple goal of trying to build language around the idea that the core of the language is not special in any way, right? That you can take the things that are implemented in the core and you can implement them in the libraries just as well, right? That you don't need things to be in the core to gain some special powers. Everything is at the same level. And this is achieved through two mechanisms. And one is macros, and the other is protocols. So this is, for example, a test module. And I think what is also very interesting is that macros and the system allows for some great features of the platform. And one of those is exactly related to the tests. So for example, let's say we have some assertion when we assert that two maps are the same, right? But we have a bug, right? We have an issue. Elixir will highlight for us where the difference is, right? And this is maybe not that impressive of such a small map, but imagine a map within a map and each has 20 keys and try to find the one letter difference. It's very hard to do when you stare at it. But with macros, you can transform the simple equality operator into this awesome message, right? In most languages, with assert and equals, you would get, well, expected true, but got false. It's now your turn. But Elixir is able to help us. And here we have an example of using Ecto, which is, and in particular, the DSL for building queries, where we can see that we are able to build this in a way separate language inside the language itself, leveraging macros. If any of you have experience with .NET, you will immediately find a similarity to Link. And the interesting thing is that Link had to be introduced into core of C# itself. But Elixir, having this extensibility through macros, this can be built as a library, which is it's a subtle change, but it's also very important when you try to steer the development of the language, because a lot of experiments can happen outside the core. And similarly, this means a lot of Elixir is implemented actually in Elixir. One of the examples is the if macro. And if you look at the kernel modules, so a lot of things are just macros. So things like def module or def macro itself is a macro, which is a bit, this turtles all the way down situation. So going to the productivity now, and this part will relate to the Božedar's talk from the morning again, because talking about productivity in Elixir, the thing that is always in the first place is documentation. I did a quick run through like line counting tool, and it told me that Elixir core is 40,000 lines of code and 20,000 lines of documentation. Right? So documentation really is a first-class citizen in the language. And there's a lot of tools which makes it that the documentation is like this, not only of the core language, but also of the libraries. And we have the same idea of doc strings, but it's formatted using Markdown, so you don't have this problem with ambiguous format. And something that is pushed hard by the core of the language is that you have a lot of examples, and those examples are actually executed as part of the test suite. And this means that people writing libraries see these standards of writing documentation, writing examples, and they are doing the same. So if you look at the libraries and packages in the Elixir world, a lot of them have very good documentation with a lot of examples. And another part of the productivity is the Hex Package Manager, which is tightly integrated with the documentation part I talked about earlier, because a companion to Hex is Hex Docs, which hosts all the documentation for Elixir, for all the packages. So you have all of them in a single place. You can access any version you want, any package you want, in the same way. And here I wanted to touch also on the bit about editing the documentation and contributing back. So let's say you have the length function and you found some bug on the website. Well, you can click on the little thingy in the right corner that takes you to the GitHub source. Then you can click on the little edit button and GitHub will open an editor for you. And you can write your commit message and open a PR right from the browser without downloading or cloning anything, right, within 5 minutes. I actually didn't know you can edit code on GitHub like that. I learned about it recently. And I started doing a lot more documentation pull requests because it's so simple. So now I wanted to do a short demo of the new features we got in Elixir. I hope it will work. First, this. Okay, can everybody see this? I think so, right? Okay, so let's start the Elixir shell. And the two parts about productivity that we got really improved in the last releases relate to debugging code. So before, when you call the function that broke, right, that didn't match, you'd get this horrible message that basically said, well, there's no clause matching what you gave me. Go ahead and try to figure out what went wrong. But with 1.5, you get this error message that explicitly tells you what arguments the function was called in, but also shows all the clauses that the function defines and all the reasons why they didn't match to your call. And it may seem like a small thing, but it's actually very huge, because this is probably one of the most common exceptions you get when you call with the wrong argument or wrong type or something like that. And it speeds up development so much. Another great feature is breakpoints that you can set right from the REPL. So let's say you want to set a breakpoint on your decode query function. And then when we call the function, we will get a breakpoint with source code. We can explore the variables, and we can write open, and it opens the place in our editor. Those are the small things, but they make the development in the language so much easier. And it works with standard library, it works with the libraries, it works with your code, basically with everything. Yay, the demo worked. So yeah, let's continue. Oh, let's continue to the other goals, the new goals. So we kept productivity, and we saw the new things we got. So let's talk a little bit about maintainability. And the things that give great maintainability in Elixir are first immutability, and we talked about that throughout the whole conference today. So I won't reiterate, but also pattern matching, right? That we saw earlier, that we can assert on the types of arguments, and it makes, even though Elixir is a dynamically typed language, it's very different from, I would say, classical dynamic languages like JavaScript, Ruby, or Python, in that you assert the shape of the data and the types of the data much more often than you do in those languages. And this makes the sort of bugs in the code that, for example, you pass an integer instead of a string, much, much rarer, and they are caught much more sooner, even though you don't have the static analysis with a regular type checker. Another one is testing with XUnit. When tests are easy to write and easy to debug, you want to write them, and code that has a lot of tests is easy to debug. Similarly, we talk a little bit about in the extensibility part about protocols, but they are great for establishing contracts between parts of our software. So they are explicit, and we can rely on them and document them. And here we come at one of the big rules in Elixir that it got from Python community, which is that explicit is better than implicit, right? And we got reference today to the great talk by Rich Heike, which is Simple Made Easy, which talks about the difference between simple and easy. And a lot of time, an implicit code that hides implementation is very easy to write, right? For example, you add one line of code and now you have an admin panel or whatever. But when you're trying to understand what's happening there, it's not simple in any way, right? And being explicit about those things, even if it makes you write a little bit more code, makes it easier to maintain this code in the long term. Another example of that is Phoenix, so the web framework for Elixir. When you generate a new application, it actually generates a lot of code for you. And this code basically establishes all the conventions in the framework, which means that they are in your code and you're welcome to change them. They are set explicitly. So you get the best of both worlds. You get the quick iteration on the convention over configuration thing, but you also get the flexibility to change it when you don't like the convention. And the last part of maintainability that we're probably gaining soon in Elixir is property-based testing. That is released in a separate library for now and is scheduled to be included in Elixir Core in 1.6 in the early next year. We'll see how that goes. And the second point is reliability. And a lot of it comes from Erlang. So things like isolated processes and fault recovery with supervisors. But Elixir also develops new abstractions around those ideas, and the primary one being the gen stage abstraction, which I don't have time to go into, but is basically flow programming for Elixir, which is based on the idea of back pressure, so that you cannot overload your system. Okay, so I guess now all of you have just one question in your mind, and it is, how do I start with Elixir? So we have this great website with the getting started, and the guides. And I would really recommend it to you. That's how I started with Elixir. If you're interested in web, Phoenix is a great framework for that. And we have another great framework in Elixir called Nerves project, which is actually around building software for IoT devices and small devices. It allows you to build your software for like those small boards like Raspberry Pis or BeagleBones in Elixir directly, and your board boots directly through Elixir, and you control everything from Elixir. In the US, in the ElixirConf, there was a great talk about a guy who built basically artificial pancreas for his diabetic wife in Elixir. I don't have a link for it. I'm sorry about it. I will edit before I publish the slides. I really recommend watching it because it's really mind-blowing what you can do with it. And there's a bunch of links to the things I mentioned. Thank you very much.